So I got tasked with cover crops in North Dakota systems, which was pretty daunting to me on how to approach it and going through all the data. So I'm going to go over some summarizations of similar work and a little more depth on a few of the concepts. I did a quick search just for NRCS, and this is what I saw from their website. So for cover crops, they're looking at protect and improve soil erosion, improve soil structure, improve water infiltration and retention, increase soil organic matter, break up soil compaction, increase soil biology and diversity, weed suppression, and reduce salinity. So when I looked at NDSU's website quick, what they said when you search for cover crops is they use them to improve soil health, provide cover to unseeded ground, increase water usage, manage salt issues, provide grazing and forage opportunities, break up soil compaction, and fix nitrogen. So when I think of cover crops and utilizing them, here's the rationale that I use. It's like, what are the issues we're trying to address, or what are our management goals first? Then I look at what my restrictions are. Is it the length of the growing season left and temperature? Is it lack of or excessive moisture? And then another thing we need to be very cognizant of is our residual herbicide programs from last year or what we're going to use this year. And if you look in the 2026 weed control guide, pages 105 and 106, they give a pretty good list of how the different herbicides impact a lot of the common cover crops used. So next, I look at what are my potential entry points for this cover crop. Are we looking at after harvest? Are we going to try to do this within season? Are we going to do a full season cover crop, or are we in a PP situation? And then I look at what are my potential establishment methods. Can I use a drill or planter to get this stuff in the ground, or am I restricted to broadcasting? And then lastly, I look at what are my termination methods. Is this something that's going to winter kill if I'm doing a fall cover crop, or is this something I'm going to need to terminate with a herbicide or with a roller crimper? So the most logical entry point is after small grains or pulses. It works really great south and east of here where they have a longer growing season and higher precipitation. What I found here in at least central North Dakota is that I have between 24 and 36 hours after combining when I take that canopy off where I have enough moisture to get my cover crop seeds to germinate. If I wait later than that, then my cover crop germination is determined by the next adequate rainfall event, which might be days or weeks from harvest. And that's the difference between a cover crop that's 2 to 6 inches tall and something that could be from 6 to even 18 inches tall. And for most operations, combining at the seeding at the same time would be a real challenge because this is one of our choke points for labor. I mean, it's always in short supply at this time of year. So this led me to ask the question, where are opportunities within the growing season to successfully establish a cover crop? So in 2025 through 2028, we use barley as our main crop, and the locations where this study was done was Carrington, Langdon, and Minot. And the mixture we used was turnips, radishes, lentils, and flax at 20 pounds an acre. So we had a check with no cover crop. We established our cover crop at seeding, right down the same tube. We came back at 4 to 5 leaf broadcast, which would be your typical herbicide application. And then we came back again. Another treatment was at anthesis, was your typical fungicide application. And then the standard practice of after harvest. And what we saw those 3 years is we had no impact on barley yield by any of the cover crop treatments. However, if you're growing barley for malt, you have mature black radish seed, some a little bit in the seeding treatment, and you can get some green radish seed in the 4 to 5 leaf treatment. Just something to be cognizant of. When we look at the biomass treatments, that 4 to 5 leaf treatment was higher than all the other treatments. And at seeding treatment was significantly higher than the at harvest and no cover crop check. So I continued looking at this study from 2019 to 2023 in hard red spring wheat, just at Carrington, and Glen was the variety that I used. And within wheat, we saw that the at seeding and 4 to 5 leaf treatments were significant. Well, 4 to 5 leaf drilled treatment that we added were significantly higher than the check for biomass production. This last season, with Dr. Perez out of Fargo and Leo Bordelone in Minot, we initiated a trial looking at cover crops during and after wheat, and they'll go to soybeans this next season. So the picture on the left shows you what the trial looked like at the end of the season when we did our biomass cuts and also our weed counts and weed biomass. Oh, sorry, I forgot to. So the picture on the left is what I was explaining. This is what it looks like at the end of the season when we did biomass and took our weed counts and biomass. And this picture on the right just shows you we took 2 quadrants out of each one of those plots. So when we look at the above ground biomass produced in these treatments, first I need to go through that. Treatment number 1 was hard red spring wheat that we terminated shortly after germination. Treatment 2 is just hard red spring wheat volunteers. Treatment 3 is hard red spring wheat plus 8 pounds of turnips and 15 pounds of hairy vetch broadcast at Feeks 10.5, which is flowering. And then treatment 4 is that same cover crops, only we seeded them after harvest. Treatment 5 was 80 pounds of rye broadcast at flowering. And treatment 6 was the rye seeded after harvest. And we didn't see any difference in Carrington in the total biomass, statistically in the total biomass production. However, in Minot, that treatment 3, the broadcast hairy vetch and turnip produced significantly higher biomass than the other treatments. And the at harvest, after harvest seeding treatments were significantly higher than the rye broadcast. Now we're looking at canopy cover, and as you would expect, the higher biomass production you have, again, the greater canopy cover that you have. And it followed the same trend as the previous slide. Next, we're looking at weed biomass. And again, as you would expect with the higher cover crop biomass production that we had, those treatments had significantly lower weed biomass produced, both in Carrington and at Minot. And this is what you'd like to see when you're doing cover crop treatments. We saw no negative impact on our wheat yield with any of the cover crop treatments used. So looking at both sites, treatment 3, which was the hard red spring wheat volunteers with the hairy vetch and turnip broadcast at flowering, was our best treatment. It had the highest soil cover crop biomass coupled with the lowest weed biomass. And the turnips and hairy vetch established really well effectively in the broadcast situation. Also, hard red spring wheat alone could be a viable option as a cover crop. And Rye did not perform well broadcast. That's something that we're going to need to get in the ground to see the best benefit from it. So this is presentation is about the whole state. So I'm trying to get some of the Western info out to you guys as well. So this is wheat with cover crops. This was done in Minot in 2023. And they looked at just the same timing as the previous study where we're looking at just the flowering treatment. And they took cover crop biomass, soil cover, and moisture as well. So what did they find? If you look on, well, first off, let's get to their treatments. They had no cover crop, rye plus red clover and radish, rye plus winter peas and radish, rye plus forage sorghum and sun hemp, and rye plus hairy vetch and turnip and radish. So importantly, they saw that there was not an impact on wheat yield. And if we go over to the right, you see that column that says cover crop biomass. We see significantly higher cover crop biomass in all of them versus the no cover crop. And we see significantly higher cover crop biomass in the rye, hairy vetch, turnip, and radish versus the rye, forage, sorghum, and sun hemp. When we look at which translates into, the same percent ground cover was higher with those higher biomass treatments. And when we look at the two columns on the right, we see that there was no negative impact on available moisture at the end of the season in November for our next crop. Next is something that isn't new. This is something that our European ancestors did when they settled in this part of the country. But they only had alfalfa and sweet clover as their only options at that time. So the picture on the left shows crimson clover within the wheat, and the picture on the right is red clover within the wheat. And this study was done 2018 through 21 in conventional tillage, and then from 2022 to 2023 in no-till. So again, our ancestors only had sweet clover and alfalfa. We have a lot of different things that we can try now. So kind of based on some literature and just kind of the architecture of a lot of these plants, I tested all these different legumes. We had Indian head black lentil, Alsike clover, balanza, berseem, crimson, Cuban, Persian clover, which are all fairly low growing. Well, the balanza and berseem can get, a little bit taller at a foot or so. Cuban clover is really tall. Persian is short. Red clover, subterranean clover is very short. Sweet clover is kind of our cover crop check. And then we had some barrel, burr, snail medic, and bird's foot trefoil. So these trials were grown with no nitrogen fertilizer, both the first year and the second year. And we did not see a negative impact on wheat yield or any of our protein or test weight from any of these legume treatments. The crimson clover and red clover established the highest stands, followed by the medic species. Cuban clover and subterranean clover were significantly higher than sweet clover and the remainder of the treatments. Treatments with successful establishment had green ground cover immediately after harvest, maintained this throughout the season, which prevented wind erosion, gave us living roots to extend the life cycle of some of the microbes, and also potentially prevented some of the new weeds from germinating. Switching gears, we're going to look at rye before soybeans and dry beans. A lot of this work was done by Dr. Franzen and Abby Wick in the Valley, and then out here at the Carrington Center by Sylvia Yuha and Greg Andrews. Now, the studies looked at various things like erosion, weed control, salinity, mitigation, and iron deficiency chlorosis. What are the restrictions from a lot of these studies? Is that the available moisture in the top 0 to 6 inches. So rye can use 2 to 4 inches of moisture, depending on how long you let it grow. And the take homes from these trials are that in eastern North Dakota, there's a yield penalty for terminating rye under normal field conditions if you terminate after seeding. Switching gears, we're going to look at cover crops during and after soybeans. So again, what are the management issues or goals we're looking at? Wind erosion, keeping something growing. Some of the studies are looking at biofumigation for soybean cyst nematode and white mold. Again, the restrictions. Again, that moisture in the top 0 to 6 inches. A lot of these studies, they looked at rye or rye in combination with winter peas and spring and winter brassicas. Take home from these trials is we can reduce wind erosion, we can scavenge in, and in eastern North Dakota, there's no yield penalty if we terminate at R1 or earlier. Shifting gears, we're going to look here at western North Dakota now. This study was done in 2023, and it was done in Minot, Williston, Nesson Valley, Dickinson, and Hettinger. They looked at soybeans in 2 different row spacings, narrow at 7.5 to 10 and wide at 22 to 30. They had 2 timings, R2, which is full open flower on the top 2 nodes, and R5, which is the beginning of seed. So you'd have a 1/8 inch bean in the pod at the uppermost nodes of the main stem. The cover crops they looked at were rye, rye plus winter camelina, rye plus canola, rye plus oats, and radish. So all sites were harvested. Williston and Nesson were lost to hail. There was little to no cover crop that grew in Dickinson or Hettinger. Basically, it's due to not enough moisture, uneven moisture. And more in Minot, the cover crop established well, and they collected biomass, stand, weed count, soil cover, and soil moisture. And this just shows that, their seeding date for the soybean was June 2nd. The cover crops were seeded at, the R2 was at July 16th, the R5 was at September 15th. They combined on October 16th, and they took their soil moisture and cover November 17th. So what did they find? In the narrow row, there was no negative impact on soybean yield, test weight, protein, or oil. When you look at the cover crop biomass column, there was, as you would expect, the earlier you seeded the cover crop, the more biomass produced for the most part, which again correlates to the amount of soil cover that's provided. They did soil moisture in November, and they found that there was no negative impact on these cover crops for the available moisture at the end of the growing season for the next growing season. When they looked at the wide rows, again, there was no negative impact on soybean yield, and they had the same trend where they had higher biomass production with the earlier seeded cover crop. And again, no difference in water at the end of the season. So now we're going to look at cover crops before soybean. If we think back to that picture where we showed the wheat stubble with all the different cover crops in it at the end of the season, now we're going to seed soybean into that trial. And what are we going to try and look at? We're going to look at erosion, weed control, and can we make the soybean plants pod higher? What are the restrictions? Again, soil moisture and the rye and hairy vetch cover crops overwintering, the brassica cover crops scavenging in. What are the potential take homes? Does soybean growing through all this biomass affect grain yield? Can we make the soybeans plant higher? And if we can get them to pod high enough, can we get by without rolling to reduce wind erosion even further? Switching gears, we're going to look at interseeding cover crops in the corn. This is almost a full season cover crop. This study was done in in Mandan from 2018 to 2020. And if we look at the pictures on the left, there's control with no cover crop. The next picture to the right is our first planting date, and that would have been at V4 corn. The second planting date is at V6 corn, and the last planting date is at V8 corn. And the mix that they used was rye, spring triticale, purple top turnip, and cowpea. So this graph, they looked at cover crop and above ground weed biomass. And when we look at the first planting date timing, which is the V4 corn, they saw significantly higher cover crop biomass production than the other treatments. And again, they found no significant difference in yield based on any of the cover crop treatments. So we looked at 60-inch corn in Carrington and at Oaks. So the picture on your left is after harvest, what it looks like in 30-inch corn, and on the right is 60-inch corn. So here's how we do this in Carrington. We just chain up the rows that could impact our corn row. There are companies now that make some really nice high clearance seeders for this application. So the results on the left is our Oaks location, on the right is Carrington. You can see that we looked at different populations. 32,000 was our check population in the 30-inch rows to compare it to. We backed off on some of the populations in the 60-inch row just to see what that impact was on yield, because instead of plants being 5 to 6 inches apart, now you've got plants that are 2.5, 3 inches apart within row to keep the same population. There's been a lot of debate on whether north-south or east-west rows are better. This study shows that it's pretty inconsistent on which row spacing or row orientation is better. And then if we look at the bottom two rows, this is what's most important. So if we look at in Oaks, there's roughly a 13% yield reduction by planting in the wide rows, or 28 bushels. And at Carrington, there's roughly 5 to 6% yield reduction by planting in the wide rows, which is about 6.5 bushels. In Iowa and 15 on-farm trials, they saw a 12% reduction in yield. Switching gears, we've got cover crop variety trials. So Marisol and Fargo has been doing this for many years, and Leo and Minot started this last season. So they're planting various cover crops to look at their potential adaptation and performance in North Dakota. And they've primarily looked at brassicas, a lot of different legumes, lots of different cereals, warm season annual grasses, and please contact them if you have any specific questions about varieties. So now we're going to look at cover crops in a PP scenario in saline areas. So I've tested 35 species in these areas. We looked at warm season broadleafs, cool season broadleafs, lots of different ones. For our warm season broadleafs, we found that sunflower and safflower established the highest stands. And in the cool season broadleafs, camelina and Ethiopian cabbage established the higher stands. However, a lot of the other cheaper crops in there, like rape, radish, turnip, and beets, they perform pretty well as well. With the perennial legumes, in this study, we tested sweet clover, Berseem clover, bird's foot trefoil, crown vetch, hairy vetch, and Persian clover based on the literature. And we tested a few annuals as well. The sweet clover and bird's foot trefoil performed the best out of those perennial legumes, and the annual legume, Sesbania, produced by far the highest stands, but the seed cost on it is just way too prohibitive to use in this scenario. The warm season grasses we tested. We also tested some cool season grasses. The Siberian millet and sorghum Sudan grass produced our best stands for the warm season grasses. And the cool season grasses, barley was our best treatment, followed shortly by rye. And lastly, this is what everybody wants, or a lot of people want to find out is, are there potential N credits from our cover crops? Well, from here in North Dakota, from all the studies that Dr. Franz and myself and the others have done, we have not seen an N credit in season or in the following crop season. A lot of Dr. Franzen's studies saw an N tie-up of 20 pounds or more, depending on the cover crop that was used. However, most producers, we don't want to be short on our nitrogen, so their fertilization rates are covering up this smaller increment. That's not to say that the N credits in subsequent growing seasons, it's just a matter of determining when that becomes available, and none of the studies have gone on long enough to be able to determine when that credit might be.